Good afternoon, everyone. Welcome to the first of a two-part series of Let the Research Speak, focusing on climate and entomology. This is an event organized by the Faculty of Science and Technology at the University of the West Indies Mona campus in collaboration with our colleagues and partners from the University of Illinois, Urbana-Champaign. Today, we're gonna have some discussion and we will hear from our colleagues in terms of what it is they do. They will actually be letting their research speak for them. We invite you to ask questions and put that in the chat for us. And as soon as at the end of the session, we will take those questions. In order to ensure that we know if you're targeting your questions to any particular member of the panel, please just indicate so in the chat so we'll know who to direct the questions to. Welcome, special welcome to our colleagues from University of Illinois, Urbana-Champaign. Welcome to those listening in and participating in this as usual. And we look forward to a very informative afternoon. We will go right into the session now by introducing our first speaker. Our speakers will present for about 10 minutes. And as I indicated, please, we will have all our speakers present prior to taking the Q&A at the end. Our first speaker this afternoon will be Dr. Joshua Anzinger. He's a senior lecturer in the Department of Microbiology at the University of the West Indies Mona. He simultaneously holds the position of head of virology. He's a consultant virologist and director of Jamaica affiliate Global Virus Network. As a senior lecturer, his focus is on multiple subject areas, including microbiology, virology, disease and treatment, organ system toxicology, and immunology. I'd like to turn over the platform now to Dr. Anzinger. Dr. Anzinger, it's all yours.
Thank you very much for that introduction. Let me bring up my slides. And thank you for having me. So I was asked, I'm not in the Faculty of Sciences, as was said, I'm in the Department of Microbiology. I know very little about climatology. I know very little about entomology as well. But I think the reason I was asked to join is clearly there's a role for both of these things in terms of virology. So I'm just going to go over, this is a slide set that I've been working on for seminars next week. So I'm going to skip past a lot of it just to keep this within the 10 minutes or so. So I think this is really the most, one of the most critical slides is Jamaica and the epidemics that it has experienced basically over the last 10 years, which have been very, very frequent, as those of us in Jamaica know. Starting with 2012 here was a dengue epidemic. 2 years later, chikungunya was an explosive epidemic in 2014, quieted down after that. Then we had Zika virus epidemic at the same time. Dengue was circulating at roughly similar levels as Zika virus. And then after this, it was relatively quiet for a couple of years in 2017 and 18. And then, of course, we had a massive dengue epidemic, one of the worst in recorded history. In 2019, we had, of course, just as this epidemic was ending, we had another pandemic that was just beginning, and our first case was of COVID was in March of 2020, just as dengue was ending. We had Mpox scare. Fortunately, that did not gain much traction. And then dengue epidemic, which was high levels of dengue cases in 2023, which has subsided. It's not clear if that's going to continue on into 2024 later on as the rains come or not. And then all of this is occurring on a background of chronic epidemics that have been occurring way before this timeline of retroviruses, HIV and HTLV, which have been around for many, many decades. We can see there's lots and lots of activity in terms of viral epidemics in Jamaica. Now, I'm just going to talk briefly with the 10 minutes that I have, just about probably a couple that are the most important, just maybe a few slides each. And I think that really is in particular, as we can see here, the mosquito-borne viruses. So we can see these are very, very prominent. We have epidemics regularly occurring with mosquito-borne viruses. And of course, the vector plays a major role in that. And, that is influenced by climate. And so I'm just going to talk very, very briefly about these. I'm going to skip a few slides and just to show you that how explosive these can be. So here, this was part of a study. I think we'll probably hear more about this from Professor Christie, a larger vertical transmission study looking at arboviruses. And this was a study looking at 5 clinics in the Kingston metropolitan area and doing a seroprevalence study that basically is showing us the amount of participants, in this case, pregnant women, that had a past infection with chikungunya or Zika virus. And you can see those numbers right there. And you can see that this is massive. So 84% of the population. So this is several years after the chikungunya epidemic. And so just like those of us who were there, basically, we saw many of colleagues, friends, family coming ill with chikungunya. And then we can see Zika virus a little bit lower. I won't go into details of why that may be. Possibly dengue was circulating at that time, and there may have been cross protection, et cetera. I'm not going to talk really any further about chikungunya. I'll just mention Zika virus. We're very much interested in arboviruses, and we were actually part of a study. On the left here, you can see Zika virus and how it was spreading throughout the Americas. And basically what this is showing is a phylogenetic tree that the virus made its way from Brazil, was the first introduction in the Americas, excuse me, into the Caribbean. And basically from there, it made its way into Florida. And this lower left graph basically showing that, as expected, the inferred time of introduction was much sooner than the first actual detected case. So those little dots on the left, that's inferred when the virus actually made its way to the particular country or region, and then the length of time before the actual first case. And of course, I won't go into the details, but this was a major cause for concern because of severe congenital disease like microcephaly we see there. That led to some unprecedented things like the government advising women to avoid pregnancy. Also had a handful of cases of Guillain-Barré syndrome for the Zika virus. I'm just going to skip to dengue, and this will be the last one that I will talk about for arboviruses. And I think the other relevant thing, so there's all those viruses, almost every virus that I've mentioned, basically, we're working on, with the exception of Mpox. So I'm not going to talk. I don't think there's really much relevance for HIV, HTLV in this context, as well as COVID. So I'll just finish by talking about dengue, as we can see here. So this is just cases over the last 20 years. This is Ministry of Health data, and looking at the different serotypes and the case fatality rate. So CFR is case fatality rate. And so we can see that basically we have every 2 to 4 years epidemics that occur, and we get serotype switching. I won't go into the details of that. And we can see the case fatality rates actually vary. So they were kind of stable, more or less stable from 2007 to 2012 epidemics. 2016, Zika came along and the case fatality rate went way down. In 2019, it went way up. So there was a huge number of cases and the case fatality rate is higher. In 2023, we had a lot of cases, different serotype. And we were expecting, at least I was expecting, probably others were expecting this to be more severe, but the case fatality rate was actually lower. Not really clear. I don't think anyone has a good understanding of why sort of we've been thrown out of equilibrium in this 2016 to 2023 in terms of disease severity. I'm going to now just skip on. The last thing I will talk about, and I will finish, is our work in the Abbott Pandemic Defense Coalition. So we're an Abbott Pandemic Defense Coalition site. So for those of you that are aware, Abbott is a biotechnology company, makes diagnostic tests primarily, some medicines as well. But the bread and butter is really making diagnostic tests. And so we are a part of this coalition, as well as many other sites throughout the world, which you can see in all those dots on the lower left. These are primarily set up in low and middle income countries where there may be blinders in terms of identifying things. So these are very strategic locations that were picked. And this gives us quite a bit of information about the context of what is happening in the country. And then on Abbott's side, of course, this feeds into them. They are the first to see, basically, and can potentially make a diagnostic test if they feel that that is something of interest. So we're in a sort of a unique position because we have expertise on multiple levels on our team. So we have infectious disease clinician, for example, consultant microbiologist, monitoring accident and emergency room. So that's the emergency room in North America. Monitoring people basically daily with a research nurse for patients with a likely viral illness. Following those, these go through normal diagnostic testing. And for those that we do not have a diagnostic answer for, we actually save those samples back for sequencing. So I'll mention that in a minute. And then now on the mosquito end, we have another team, Dr. Simone Sandiford, who has, and her student here, Samoy Noble, can trap wild-caught mosquitoes, and importantly, they can speciate them. All right, so they can identify the species, they can sex them into males and females. Of course, the females are the ones that bite and we're interested in to transmit the virus. But then they can speciate them. We can pool these. We can grow these out to look for viruses. And for those that look like they have an indication of virus, we can follow this up with sequencing. All right, so without going into sort of too much detail, this is kind of the workflow. So basically, we're looking for all viruses. So this we have, without going into technical details, lots and lots of probes. And we're able to essentially identify any virus that's present. All right, so we process the sample, we enrich it for viruses, getting rid of all the other material. We have the sequencing laboratory now, thanks to COVID, and then we run through a bioinformatic pipeline and we identify the viral pathogen. All right, so these are really the things I think that are probably most relevant in terms of climate and entomology, certainly mosquito-borne arboviruses, and then perhaps identifying new viruses that may arise. Of course, there's possibility for zoonotic, it could be mosquito-borne, etc. So I will stop there, and thank you very much again for the invitation to talk here today.
Thank you very much, Dr. Anzinger. We appreciate your presentation. As you know, you did indicate you may not be around, but if persons have questions, we would ask that they put them in the chat. At some stage, we can, even if you're not here, get those questions to you, get a response, and we can share it either at part 2 or at some other time. If they leave their contact, we could pass those on to them. So thank you very much for your time and your presentation. So we'll move on to our next presenter, Dr. Trent Ford. Dr. Trent Ford is a state climatologist for Illinois. He has expertise in hydroclimatology and climate extremes, including drought and heat waves. He leads work to better understand water movement between the land and atmosphere, how these processes create or worsen extreme weather, and how we can better monitor and predict societal impacts. Through his work as the Illinois state climatologist, Dr. Trent has significant experience in stakeholder and decision maker outreach and communication of climate science. He regularly engages with communities, industries, and local to federal level agencies in Illinois and the Midwest in hazard early warning preparedness and mitigation, and helps to identify climate solutions from a local scale all the way to a global scale. I welcome Dr. Ford. Dr. Ford, the platform is yours.
Yeah, thank you very much. And thanks for all the organizers for putting this together. So I'm just going to touch very briefly on some of the climate work that we've been doing, both in the research as well as the outreach and engagement. Of course, those two things work together. And then, some opportunities for collaboration as well, both in the entomology space and in the health space as well. So text heavy here, but otherwise it would have just been a bunch of figures that would have been taken too long to go through. So, really breaking down what kind of my lab or research section is really in understanding weather hazards and climate extremes. So that is through intensive studying of the interactions, the processes, the dynamics behind what makes a weather hazard and a climate extreme, especially as it relates to water. So we do a lot of work with drought, including flash drought, and that can range from flash drought, understanding the dynamics to improve early warning, prediction, and response, but also understanding the impacts it has. But also on the flip side, excessive, too much water, which is often the case, and that relates to precipitation variability. So we're studying that using past events, but also projections of future climate change across the U.S. and in other environments as well. And then the kind of secondary piece of that is not just understanding the drivers of climate change and sort of how our extreme weather and impactful weather and climate change, but also understanding, preparing, and managing the sort of sectoral impacts of those changes and of those extremes. So we've done a lot of work with agriculture, both sort of our grain crops as well as our fruit and vegetable crops and livestock. But also with public health, ranging from everything from air pollution that can be exacerbated by drought, extreme heat, all the way to water quality issues from nutrient runoff from ag fields and that sort of thing. Also understanding the role of urban development and how development in urban and in rural areas can exacerbate or hopefully mitigate the impacts of climate change. Again, just a wide-ranging number of sectors, and like I mentioned, fruit and vegetable production, looking at aquatic ecosystem health, avian disease management. Chris Stone and I have been circling the wagon, so to speak, on mosquito incidents and management and how mosquitoes respond to climate change. Again, that's both in a historical understanding the dynamics of those interactions in the past, but then also looking at future projections, which is what we work with a lot here in the lab. I also wanted to mention that my role really emphasizes the outreach part of the research as well. So we're not just doing this in a silo, but a lot of the work that we're doing is going to actual climate resilience and disaster management or hazard mitigation. So that can be through just a couple of examples, community climate planning. So this is from a fairly moderate or medium-sized city in Illinois. We helped with their transit district to identify current and perhaps future threats from weather hazards to transit. Think about a big winter storm or perhaps an extreme heat event that can buckle roadways and rail, those kind of things, and understanding how those hazards may change in the future and what solutions may be best to implement to ensure that we're resilient to those. We can do the same thing in a healthcare space as well. And then, of course, looking at the underlying vulnerability and the climate justice issues, a lot of this work has been done in Illinois, but of course, a lot of these same threads run through the Caribbean as well, where we may have the same kind of climate forcing, the same increase in perhaps exposure to things like extreme heat, but of course the underlying social vulnerability is really going to be the main determinant of where the impacts pop up. So pulling that into a healthcare environment to understand exactly where we're going to see those issues when we have some sort of extreme climate or weather event. So a lot of this is really community-informed research. Again, putting what we understand about climate and climate change into a kind of an action framework. And so that means a lot of collaboration with adaptation professionals, civil engineers, urban planners, healthcare professionals, emergency management, so on and so forth. And then, a lot of this outreach and the research also involves quite a bit of communication and education as well. So there's a lot of public speaking going on from myself and those others in the lab, engaging with communities, special interest groups, And then we're doing a lot with climate and weather education for K through 12 schools, as well as educator training and adult education programs. And again, a lot of this is just when we talk about things like climate change, getting them to understand that there is these changes in weather and the climate that have impacts, but also that what are sort of ingrained social vulnerabilities are also going to be a big determinant of those impacts, and kind of seeing their lived spaces as sort of from those two perspectives. So the real goals of this are raising awareness and knowledge of weather, climate change, but also ensuring that the research that we're doing is public informed. So grounding those research in problems experienced around the state of Illinois, but in other places as well. And I just wanted to hit on, when we talk about climate change impacts to extreme health, I've mentioned a lot about the kind of acute impacts. We think about extreme heat. That's something that happens in the now. We see a lot of those health problems that are in the hours to days following a heat wave. Same thing with flooding, drought, and then water contamination as well. But then there's the chronic sort of impacts to public health from climate change that are really more either slow acting or perhaps more of a simmer of just kind of background issues that are perhaps harder to pick up as far as the relationship with climate change. Things like increased allergy and respiratory conditions from air quality, mold-related respiratory problems from increased exposure to flooding. We think about flooding as the damage it initially causes, but once the water recedes, having those issues from mold and other types of problems. Mental health impacts from repeat exposure. I mentioned flood, but that comes from all sorts of different impacts and sort of the climate anxiety that we hear about quite a bit, especially among youth. And then, of course, occupational health issues where folks are having to work outside or being exposed against these impacts. And then, a lot of what we've talked about for this event is the vector-borne disease. And of course, that it brings in the additional complexity of the vector itself, the mosquito in this case, or the tick, and how it's reacting to the background change in the climate in which it lives, as well as the underlying sort of environmental change that humans impose. So, there's a lot of these interactive effects that make it, climate change and health relationships really complicated and challenging, but also very exciting to study and impactful. So when we want to talk about collaboration interests from my perspective, trying to work to better understand the linkage between weather, climate, and public health outcomes across timescales. So as I mentioned, not just we have a heat wave, we're seeing these kind of impacts, but also if a region is experiencing an increased exposure of perhaps what we can consider nuisance flooding, where we just get some standing water in places, nobody's home is getting flooded out, but that kind of nuisance flooding, but you're getting that 5-6 times as often as you were getting, several decades ago. What kind of public health outcomes are unique to that? And can we use the information we have both in the healthcare sector as well as in the climate sector to try to predict when those kind of impacts are going to occur and hopefully improve preventative care? Also using sources of weather and climate predictability to improve health impact, early warning, to say that, okay, we do a pretty good job of predicting when we're going to see some sort of weather impact. It's not perfect for sure. We have a lot of ways to go for that, but can we use that predictability in the healthcare space to say this area is likely going to be affected by this hazard, and therefore we're likely to see these types of health impacts, kind of connecting the dots there. And ideally developing more effective ways of communicating potential health threats, working from research to clinic. And that's something I'm really interested in. And then also assessing solutions for improving the healthcare outcomes. So a lot of the research that in the climate space that's been done is sort of mapping the social vulnerability, mapping the hazards, mapping the problems, but not so much assessing the solutions. And so what are the preventative care and kind of the responsive care, the emergency management solutions to actually improve health outcomes in the face of perhaps more frequent and intense hazards from climate change. So again, just I really appreciate the opportunity to engage with everybody here, and I'll turn it over to the next speaker. Thank you.
Thank you very much, Dr. Ford, and thanks for, I noticed you said you're not just into identifying the problems, but going for solutions as well. So that always makes it a little bit easier to sell to the average person. So just to remind those who are joining us on our YouTube channel that we will entertain your questions at the Q&A session at the end. Please remind you to put those in the chat so that we can table those questions for you. So we move on to our next speaker. Our next speaker is Professor Tanisha Stevenson, who is a professor of climate science and co-director of the Climate Studies Group at the UWI Mona campus. She is also the Deputy Dean for the Faculty of Science and Technology at the University of the West Indies, Mona campus. Her research interests are Caribbean climate variability, climate extremes, seasonal predictions using statistical models, statistical downscaling, and assessing comparative vulnerability using aggregate indices. She has been affiliated with a number of climate variability and change projects and has published a number of journal articles, technical reports, and short monographs with several collaborators in this field. I welcome Professor Tanisha Stevens. The platform is yours.
Thank you so much, Dwight. Good afternoon, colleagues. Allow me to speak to the Climate Studies Group, Mona, and some of the work that we are doing. We're speaking to 30 years of exploration of Caribbean climate science. Great to be here, great to be talking to our colleagues from Illinois. Our context, Caribbean life and livelihoods are severely challenged by climate variability and climate change. And something that becomes necessary for us within the region is a demand for climate information at scale for the Caribbean or small islands largely, relevance for the Caribbean, and information that's useful for the Caribbean. So the Climate Studies Group, Mona, was established in 1994 by Professor Anthony Chen to explore Caribbean climate, its drivers, how it manifests, how we can predict it, what we can anticipate for future climate. And so some of the things that we try to investigate include the following. We try to understand the mechanisms responsible for mean and extreme climate. We try to develop models, statistical and otherwise, to enable us to look at climate outlooks so that we can support planning activities, whether at a seasonal, annual, or longer term time scales, such as towards the end of century. We look at climate change and how it is already manifested within the region. And we also examine future climate change. Also looking at what are the impacts already seen with respect to climate change already observed or climate variability. And we try to develop tools that make the climate information accessible or lend themselves to supporting planning and adaptation and mitigation efforts within the region. So we do so at the University of the West Indies around a coordinated climate science approach with the aim to tackle some of the barriers to us building resilience in the region. So our work is looking to how we can support efforts to better understand the variability and change within our region, what are the projections for the region, how we can support climate monitoring and climate services that are being developed for the region, provide data that supports adaptation and mitigation programs, do and support sector modeling, and also to develop tools that would support decision-making or make data sets available for the region. Allow me then to speak to three of the kinds of questions we try to answer for the region, two of the tools that we have developed, and one partnership that we have developed over the years. So allow me to speak to three of the questions we try to target. How has the climate already changed for the Caribbean? And so we try to investigate multiple hazards. We have looked at intense rain events and how those have changed. The blue showing us areas where we have seen increase in the intensity of rain events for the region. And here we're using meteorological data sets collected by our meteorological services across the region. Where you see the triangle completely shaded, the increase is statistically significant. The red shows decrease, and we're not shaded. The change is not statistically significant. We also try to support efforts to monitor climate change each year and the variability each year. So looking at annual rainfall anomalies for the region and how they compare with previous events. We look at trends in warm nights. For us within the region, we have been seeing increases in warm days and warm nights. More so for warm nights, that trend is larger than the daytime temperature trends. And we try to, an interest area we have as well is attribution. How can we now move to linking these with changes in climate? So not just identifying the actual climate change, but seeing how we can say such events are more likely under climate change than it was without climate change. We have also been looking at hurricane frequencies and intensities. For example, we have identified locations for Jamaica, for example, and within 50 kilometers of Kingston, how many tracks have we seen in between 2-decade periods, for example, between 1980 to 1999 versus 2000 to 2012, and just to see the changes in storm tracks that are impacting on the island. So that's just some of the work that we have been involved in. Also looking at what are sea level trends that have been observed across the region. We have been seeing increases in sea levels across the region. And so looking at that spatially, as well as looking at an aggregate index for the region. Another question we try to answer is, how will Caribbean climate continue to change? And in doing so, we try to look at temperature, for example, and we have seen projections that suggest even hotter times. So we have looked at temperature change, rainfall change, for example, using dynamical models. So these computer models that have our equations for atmosphere, ocean, circulations, or using statistical methodologies. And so we get a picture of a warmer Caribbean by 3 to 4 degrees by end of century. We have also looked at this statistically using statistical models, or seen patterns where the models suggest that we may have days that are up to 98% being characterized as warm days by end of century. We have looked at rainfall, and the projections suggest even drier conditions across the region. Brown showing drying by end of century, and we're looking at a map of the Caribbean. And for the more intense scenarios, we see an intensification of the drying that can be expected up to 40% drier by end of century. We have done work to look at sea level rise across the region and what are some of the initial projections for the region. And for this work and other studies done outside of the group, seen up to about a 1 meter rise by end of century. We've also done some work to look at change in tropical cyclone frequencies. And we understand that where frequencies are concerned, different models have suggested different changes in frequency, so no consensus there. But as we step back and look at more broadly, other studies done, we can speak to more intense storms impacting the North Atlantic and the Caribbean, and more rainfall and higher winds impacting us. A third question we try to treat with are, what are some of the impacts on the Caribbean from climate change and climate variability? And so allow me to highlight just a few of the studies that would have been done, looking at climate variability and its impact on human leptospirosis cases. And so in this study, we used wavelet analysis, trend analysis, to determine that peaks in rainfall and declines in temperature are the variables that are most impactful in this study for leptospirosis cases, and seeing that there tends to be a jump in these cases during El Nino events. We've also looked at characterizing heat stress on livestock, and where we can see that based on historical periods, it is very likely that our livestock are already experiencing heat stress even in the cooler parts of the year. And certainly as the temperature continues to rise globally, certainly another 1.5 degree warmer globe, we anticipate that livestock would experience year-round heat stress. Also looking at vulnerability using an aggregate index approach. So looking at some indicators of socioeconomic influences, looking at demographics, looking at climate, creating an aggregate index that allows us to look at differential vulnerabilities across the region, and to suggest under climate change, the vulnerabilities are intensified. We have looked at rainfall and runoff simulations with one of the tools that we have developed, and how previous events such as Hurricane Ivan has impacted flood risk with respect to the Jamaica Hope River watershed. We have also sought to characterize bushfire variability and how this is linked with climate change, and how we can use different indicators to then project what is the potential for bushfire incidences within Jamaica towards middle and end of century. We have also participated in global studies looking at climate change and pathways used by pests, and looking at the impact of climate change for pest distribution. So those are just three of the questions. We look at variability, we look at dynamics. And so we want to switch our attention to two of the tools that we have developed to enable planners to access information around climate change more easily, and to allow persons to explore a little more what a change in climate within the region means for us. So one of the tools that we have developed is a simple model for the advection of storms and hurricanes. It's a simple advection model. It allows us to look at the impact of storms that have traversed the region in the past, and allows the user to define their track, their forward speed of this historical storm, and looking at, by grid of an area of interest, looking at the rainfall and winds that could have been anticipated for that location had the storm passed that area. And this is a tool that's available online. So this tool allows you to create a simulation, to select your country of interest, to create a path over which you wish to pass a storm, to select a storm from a database of storms that we have, to select a category and forward speed, and then to run a simulation that will allow you to have a grid over your area of interest, and for any particular grid to look at the rainfall rates and the winds that could have been experienced at that location for that forward speed for that track. It's not a real storm model. It's not a prognostic model or nowcast model. What it's really just helping us to do is answer questions of what if, especially as we anticipate an intensification of storms traversing the North Atlantic and the Caribbean. A second tool we have is the Accept portal online. And Accept is a project initiative. It was funded under the pilot program for climate resilience. Accept just means the agricultural climate change evaluation for production, transformation, and resilience. And what it's really doing is allowing an online access to predictions of yield and biomass for a user who is defining a particular scenario of water availability, present and future climate, and management options. And so a user can select an area of interest within Jamaica. The tool allows the data to be accessed from the nearest weather station. It allows a selection of crop, and it allows an output of in-season and final yield and of biomass. Let me end then by speaking to one of the partnerships that we are currently involved in. We are currently a part of a Caribbean climate modeling consortium. What our aim really is across our islands to provide Caribbean climate information at scale to the region, looking at the variability that has already emerged and projecting towards end of century, importantly, to support national and regional planning. And so we treat with a number of things that are crucial for the region: water, energy, agriculture, tourism, health, as some of our examples. The consortium has been crucial to investigating the implications of a 1.5 warmer world on Caribbean life, looking at hydropower, for example, agricultural productivity, damages, aridity, and allowing us as a region to be able to suggest and to provide information globally that at a 1.5 degrees Celsius warmer world, we're talking about a 40% decline in hydropower, diminished agricultural productivity, 2 to 3 times more costs associated with damages, and increased aridity or dryness within the region. and greater coastal inundation. And so these studies remind us that 1.5 is by no means an ideal state. It really represents a compromise for us within the region and other small island developing states. And so this work would have been important to characterizing what a 1.5 or 2-degree warmer world means for us within the Caribbean using global large gridded models across the region, but then taking that information and looking at grids that are smaller, so regional climate model data sets that are more representative of small islands, and looking at what the Caribbean will look like under a warmer globe, and also looking at implications for hydropower, for livestock, and for other areas of Caribbean life. I will stop there. This is just a synopsis of some of the work we're already doing. And we also have interest in attribution, in further characterizing heat extremes, compound events, flash droughts, and also in looking at climate change under urban settings within small islands. Thank you so much, our colleagues.
Thank you very much, Prof. Tanisha, for that comprehensive presentation on the work of the Climate Studies Group here at Mona. So moving on to our next speaker. Our next speaker is Dr. Sabina Samarasinghe, and she's an assistant research assistant with AI Climatology, Illinois Water Survey at the Prairie Research Institute. She's a data scientist with a PhD in computer engineering, and she has over 2 years of postdoc work experience. Her expertise lies in using interdisciplinary data-driven research to tackle real-world problems in earth sciences. She has extensive experience using statistical and machine learning approaches to analyze data, develop predictive models, and gain insight into the potential cause-effect relationships between different variables. I present to you Dr. Samarasinghe.
Thank you for that introduction. I'm Savin Samarasinghe. As it was mentioned in the introduction, I work on artificial intelligence for climatology. I come from a background in electrical and computer engineering, so I'm not a climate scientist myself. And over the last few years, since 2015, I have been collaborating with several climate scientists and geophysicists to work on applications in data science and machine learning for applications in earth science. So today I will give you a brief overview of the type of work or the focus areas of my research so far that are connected machine learning with climate science. And like the previous talks, of course, gave very in-depth discussions about how climate science and health and entomology connect with each other. I will also try to briefly extend and connect my research relating to health research. So, as you're probably already aware, machine learning is gaining a lot of popularity. As a very useful tool to create predictive models and also tackle very difficult problems in many application domains. Here in our research, we are focusing specifically on using machine learning to create climate forecasts. So what's helpful about machine learning is that these approaches really allow us to extract information from multiple, very diverse data sources. We can work pretty easily with spatiotemporal data, which is very important for climate. And also these provide very useful tools to model complex and nonlinear dependencies, and also learn high dimensional interactions from data. A lot of my previous work has focused on using deep learning approaches or approaches that are based on neural networks to create both deterministic and probabilistic forecasts of climate variables such as surface temperature and precipitation several weeks to months into the future. And I'm currently also collaborating with Trent to predict climate extremes, specifically flash droughts. Here we are focusing specifically on multi-week to seasonal timescales, or 2 weeks to 6 month type timescales, which are relatively longer than the usual weather timescale, which is 1 to 10 days. And these timescales can really provide a value to stakeholders who are really looking into decision making and planning relating to taking preventive actions, for example, related to disease outbreaks. When we talk about the predictability in these timescales, this multi-week to seasonal or sub-seasonal to seasonal timescales, a lot of the predictability actually comes from several climate processes and also their interactions. Here we're talking about remote interactions or teleconnections. Here in this image, you can see several climate processes. Here we have the Magellan Oscillation in the tropics and the North Atlantic Oscillation. These processes are remotely interacting with each other, and also they're influencing other remote locations. A lot of my previous research has focused on trying to understand how these different processes interact with each other, and also at what time scales or how many days does it take for these interactions to happen. For this, we used approaches that are based on probabilistic graphical models, where your variables of interest are represented as nodes of a graph, and the probabilistic direct dependencies between them are represented using arrows. So here you can see an example of 3 climate processes: the Magellan Oscillation, North Atlantic Oscillation, and the stratospheric polar vortex, how they are interacting with each other. And also these numbers tell us the timescales at which they interact. So here I'm showing an example of climate processes, but these approaches can easily be extended to include climate, health, and also entomology related variables. So I talked about how machine learning can be very useful to create skillful climate forecasts. But a big challenge of using machine learning as for actionable things, or where a stakeholder wants to actually use the machine learning model and make a decision, is that the biggest challenge with these approaches is that these are black box models. So we might be working with neural networks or tree-based models like XGBoost, random forests. These models can create very skillful predictions, but but we have no way of understanding how or why this machine learning model made its decision. For example, here I'm showing you a black box cat classifier. This model is, once you give it an image, it's going to tell you, is this a cat or not a cat? And it's trained on a very large number of images. So when you give this image, the model will tell, oh, it's a cat or not a cat, based on like how good this model is. But you won't really know why it made this decision. To address this issue, now explainable machine learning methods. If you read about this, you'll hear like methods like Shapley additive explanation, integrated gradients. These methods actually provide us with an explanation interface to get an understanding of how or why the machine learning model made its decision. So in this case, when it gave the cat's image, the machine learning model actually made the decision, okay, this is a cat. But the explanation tool tells us, oh, this image has fur, whiskers, it has these cat ear-like features. So that's why this model decided that this data sample is a cat. So getting this type of explanations really help us establish trust, which is really important when we are focusing on action-oriented end users. So whenever we do our research, when we create our prediction models, we always use these explainability methods to try and understand what are the sources of predictability, or what are the patterns or signals in the input data that really helped this machine learning model to come up with its prediction. So that gives a brief overview of the type of scientific questions that I've been thinking about and how I've been using machine learning to tackle these questions. Of course, creating skillful climate forecasts, trying to model climate, health, entomology-related interactions in themselves can provide us a lot of value. So looking at the literature so far, this is definitely a new research area for me. However, I feel that the work that I've done so far can and the methods that I've been using so far can easily extend to these applications in entomology. So looking at literature, I came across several studies, for example, looking at modeling dengue risk, modeling and forecasting mosquito population. In these approaches, they use machine learning models to create nonlinear predictions, and also use explainability tools to really understand what's going on with these models, or what were the important predictors, what were the important patterns. So using these approaches, we can actually use multiple sources of data to create skillful prediction models. For example, we can use weather measurements and climate model data related to temperature, precipitation, humidity. We can even use satellite data that gives us information about the vegetation cover, elevation, and also utilize socioeconomic demographic information such as poverty, population density. These machine learning approaches really help us to leverage information from these very diverse data sets to come up with skillful predictions. We can evaluate how these things change with space and time, learn the nonlinear and complex dependencies, and also get insights, learn things that we don't already know using the patterns that are identified using the explainability methods. And also using machine learning along with the climate change projections will help us understand the future implications in the context of climate change. So those are some of the directions I see that can be used, that I see machine learning can be useful for this type of research and this type of collaborations. Of course, these are only a few machine learning methods. There are lots of machine learning approaches. So the potential and scope to use these methods to tackle these relevant questions is almost limitless. And my hope within this collaboration is to talk with you, engage with you, both climate scientists and domain science experts in health and entomology, and identify what are the data sources, what are the questions that are important, and then try to investigate how machine learning and data-driven approaches can be useful to tackle these questions. Thank you.
Thank you very much, Dr. Samara Singh. I can see your passion for machine learning, and so we're excited to hear about it, and we'll certainly explore how it can help us better understand what we are trying to. Thank you very much for your presentation. Again, I just at this time would like to remind those listening in on the YouTube channel that you can put your questions in the chat, and at the end we'll have a Q&A session where we will pose your questions to members of the panel so we can get a response. Okay, so moving on, and our next presenters, Dr. Chris Stone, Dr. Andrew McKay. I was advised that Dr. Stone will speak on behalf of the team, so I'll introduce them both. Dr. Chris Stone is the lead of the Medical Entomology Lab at the Illinois Natural History Survey at the University of Illinois, Urbana-Champaign. His background is in population biology, mathematical modeling, ecology, behavior, and control of vector-borne diseases. His current areas of focus include surveillance of vectors such as mosquitoes and ticks and the disease agents spread by them, the ecology and behavior of West Nile virus vectors and invasive mosquito species, the development and testing of novel control methods and population genetic and vector pathogen interactions. Dr. Andrew McKay is an associate scientist with the Illinois Natural History Survey at the UIUC. His broad interests include the ecology and behavior of mosquito vectors and impact of environmental change on mosquito-borne disease risk. Andrew is currently managing field surveillance efforts in a multi-year project investigating mosquito community structure and mosquito-borne arboviruses of medical and veterinary concern across the state of Illinois. Dr. Stone, I welcome you to the platform.
All right. Thank you so much, Dr. Robinson. Thank you so much. Thank you so much to the organizers and our colleagues at UWI. This is really exciting. So I'll try to go through this a little bit quickly for the sake of time. What I'll do is share a little bit about what our group here does, and then what I see as some potentially interesting areas about surrounding Aedes aegypti, dengue, and climate change. Maybe highlighting some potential areas to start thinking about collaborations. So very briefly, this lab where Andrew and I both work is the INHS, the Illinois Natural History Survey Medical Entomology Lab. It's a state-funded, funded by the state of Illinois Medical Entomology Lab. It's been funded for over 30 years now. I've only been there for 6, so a long history before me. And we have a legislative mandate to perform research on disease vectors associated with use and waste tires and sort of container breeders in general. And a lot of what we work on is things like Aedes albopictus and Culex pipiens, the local species of interest, but we also do work on Aedes aegypti from time to time. So the kinds of questions that we're really interested in, a lot of it centers around trying to understand better how the environment in all kinds of different forms has an influence on mosquito-borne disease transmission. So a number of different things that we have looked at in the recent past include things like the effects of temperature on mosquito life histories, and things like immune gene expression or vector competence. So one of the figures on the left at the top left, that was from a recent paper where we looked at immune gene expression of Aedes albopictus when we reared them under different environmental conditions, so either low or high larval diets, but then also under different temperatures. And we find that those have an impact on the mosquito immune system. We've done a lot of work looking at things like nectar sources, so sugar feeding of mosquitoes and how that could affect their vectorial capacity and vector competence. So another study that we just published found that the adult nutrition, the availability of sugar, affects the likelihood of Aedes aegypti becoming infected with dengue virus here as a lab study. And then we do a number of things looking at land use or land cover and how that affects mosquito population dynamics and sometimes microbiomes as well. So in general, when we're trying to make sense of mosquito-borne disease transmission, a good starting point for that is this equation for vectorial capacity, which is really the basic reproduction number of vector-borne diseases, but leaving out the human-related elements, so just focusing on the entomological parts. And you can then break that down into the specific traits or attributes of mosquitoes, like their biting rate, their mortality rate, their density, how long it takes for a virus to develop inside the mosquito. And by measuring all those different traits together, you can get an estimate of how intense mosquito-borne disease transmission could be. And you could make a link then to these individual components to different environmental factors like temperature. So in general, and this is a figure that's not from us. This is from a paper by Sadie Ryan. But that idea of how temperature affects dengue transmission intensity, I think has been pretty extensively studied, and I think is well understood in general. So this is an example of the kinds of curves about basic reproduction numbers or transmission intensity, how it might relate to temperature. And very commonly you see something like this, where with increasing temperatures, you do see an increase in transmission, but then if the temperature gets too high, it starts to negatively affect the mosquitoes and your transmission intensity drops again. So we have, in terms of temperature, I think that's maybe not where the biggest questions are at the moment. So some of the things that we're sort of thinking about as exciting areas for potential studies could be things like adaptation. So questions like, can mosquitoes adapt to increasing temperatures? And there's some evidence of that in the lab, but do you see evidence of that in the field? And there could be some potential for population genetics studies to start looking at questions like that. I think the idea of extreme climate events, such as hurricanes or just storms or extreme precipitation, how that has an effect on mosquito population dynamics and infection rates, I think is of course difficult to study, but is an interesting question. And then in general, the idea of how humidity and precipitation impacts dengue transmission is, I think, an interesting area. For instance, how Aedes aegypti are affected by periods of drought, if those are becoming longer or more frequent. I think that is an area that's relatively understudied. And one area that we've been kind of interested in or thinking about is how then human activities to deal with the changing climate or with increasing droughts, how would that affect mosquitoes? For instance, do we see an increased reliance on water storage containers during such periods? So there's actually some evidence, at least one study from Jamaica from some time ago by Dave Chitty and others that did an extensive container survey that people on this call might are probably familiar with or more familiar than we are. And they found a couple of interesting things there. One is that water drums were found to be really important for production of Aedes aegypti. They noted that the seasonal patterns were quite distinct from what was seen on Trinidad, for instance, and with a really high number of positive containers during the dry season. And why you would see those differences, or how common that is to see differences in the seasonal patterns between Caribbean islands, might be an interesting question. They also noted that the relationship between seasonal rainfall and productivity of mosquitoes wasn't uniform across the study community, so that maybe raises the question as to whether different parts of the island, maybe more urbanized or more rural parts, could respond differently to climate change and dengue risk. And one other area that we've been interested in, or that I think might be a good starting point, would be to see whether or how subterranean infrastructure, like household septic tanks, if those could play a role. And it's been suggested that those types of environments could moderate the effects of extreme temperature and drought on Aedes aegypti. Andrea had done some research in the past in Puerto Rico looking at septic tanks and finding that those were quite a bit more productive in terms of mosquitoes than areas than surface habitats, and provided some independence from rainfall. So I think that was a very quick overview of some of the types of works we do and the types of questions we're thinking of. And I'll want to thank mostly very much Jafia for making these connections, and our colleagues at all of you at the University of the West Indies for engaging, and yeah, hope for a productive discussion. Thank you.
Thank you very much, Dr. Stone. Much appreciated, and we look forward to exploring some of those areas that you have mentioned. Okay, so down to our final speaker, Dr. Hideyuki Terashima is an outreach data technical specialist who works with the private well group at Illinois Water Survey at the Prairie Research Institute. He's interested in a broad range of topics from environmental remediation to mining processes. He also has interests in remediation of contaminated sites. Dr. Terashima, welcome, and you have the floor.
Awesome. I hope everyone can see my screen now. Yeah, appreciate the invite to join on this roundtable discussion. Originally, my supervisor, Steve Wilson, was supposed to be the person speaking here, but because of a conflict, he wasn't able to make it. Steve is also with the Illinois State Water Survey, and he's a groundwater hydrologist that has been there for a long time. He's actually the section head of the Environmental Public Health and Information and Data Sciences section, or EPHIDS, which I am also part of. Again, I'm not sure how much of our program will be of interest to you all since we focus a lot more on outreach and groundwater issues. But today I'll be presenting about some of the programs within our section, as well as some of the more recent research that Steve and including myself have been involved with. So the EPHIDS section is primarily involved with providing data management and outreach services within the water survey. For example, we house all the state's private well logs, as well as municipal supply well logs as well. And we provide homeowners or any even water suppliers that have any questions about their wells, if they're looking for their well logs, or if they need better more information to better understand their geology or groundwater geology. We also have several outreach-focused programs, such as the wateroperator.org program, which is a US EPA-funded program to provide resources to support water and wastewater operators around the country. The privatewellclass.org program, which is also another US EPA-funded program focused on providing resources and support to homeowners with private wells. And we're also currently in the process of developing a third website, decentralizedwastewater.org, which will be similar to wateroperator.org, but we'll be focusing more on providing resources to on-site wastewater professionals. So this section, or the EPHIDS section, also includes the Water and Atmospheric Resource Monitoring, or WARM program, which manages a network of monitoring stations located around Illinois to collect, water, weather, and soil moisture data, and much more data. The program regularly receives data requests, and the data WARM collects have been used as a resource by various organizations as well as academic institutions within Illinois and across the country. Just to give you quickly go over some of the programs again I just highlighted. This is our wateroperator.org website. We started this website actually back in 2009 with EPA funding when the water survey was still a technical assistance center. Since many of the small and rural water and wastewater systems around the country were experiencing a lot of compliance related issues, we developed this resource as a means to help operators get access to more public available resources, which will help them better manage their utility. When earmarks for the funding went away, we reached out to RCAP, the Rural Community Assistant Partnership, to see if they were interested in funding this program, which luckily they were. Since then, they've been a close partner to our program. So what exactly does the website do? It serves, again, as a clearinghouse of public available resources to help water and wastewater system operators. The example I like to give is, the two main organizations that provides trainings for all these operators are AWWA, the American Waterworks Association, and WEFWEF, the Water Environmental Federation. They have large number of members around the country and even some that are international. They develop various guidance manuals that are used by various utilities. They do a lot of training and outreach, and they do a lot of research as well. Except the resources that they offer, they cost a lot of money, and for many small system rural communities, they can't really afford to purchase manuals or guidance manuals like that. But a lot of federal organizations like EPA also creates useful resources that are public available, and they're often shadowed whenever you go on Google and search for, water treatment manual. So we created this website to serve as a one-stop location to find for operators to help find those public available resources. We catalog, a lot of resources like training events that offers continuing education credits to operators. We provide a means to search for all of that on a single calendar as well. We catalog over 13,000 events every year, and our we also have a resource library database where we list over 15,000 public available resources. We also provide support to operators. So if they ever need any help searching for a certain resource, or if they need help finding certain events to help maintain their certification, they can always email us and call us, and we'll help them find those resources. Many state primacy agencies actually list us as a resource for operators, and the state of Washington actually sends their operators to our website to find training events that are available within their state. Through this program, we also developed a groundwater and well care class, which is an online self-paced course which operators can take to learn more about groundwater systems and how to properly take care of their water supply well, and learn a little bit more about groundwater geology and again how to protect their water supply. Over 30 states have pre-approved their course to provide credits to operators as well. The private well class program is our sister program, which we started back in 2014 when private wells were added to the EPA grant that we were applying in. The program started by providing a 10-lesson self-paced online class, which Steve Wilson created to help private well owners better understand how to maintain their well. We had over 11,000 people sign up for our class since the program started, and every year our program keeps growing more and more, and EPA seems to like to increase the funding for private wells as well, so we're expecting our program to grow even much more. The program itself is nationwide, and even environmental health professionals can take our class through NEHA's website to receive CEs to maintain their license. We have also taken over the National Private Well Hotline from the National Groundwater Association, and we're creating a new and more streamlined interface to allow homeowners or anyone that's trying to learn more about private wells to reach out to us and get more information on it, on best practices and how to better maintain your well. We've also developed an assessment tool to evaluate the risk and vulnerability of private wells and on-site wastewater systems, which have been used by various professionals around the country. We actually developed it in collaboration with RCAP and some of their technical assistant providers, and professionals that inspect wells have actually use this, have done studies to use this tool to inspect private wells around the country, which have given us a lot of great feedback. We also host a private well conference, which brings together private well professionals from around the country and to talk about some of the private well issues experiencing, some of the environmental health issues that might be related to private wells. The conference itself is actually free for anyone that wants to join or that wants to attend, mainly for environmental health professionals and private well professionals, but it's a great opportunity to bring all these professionals from around the country and gather in one place and discuss some of the issues that are impacting homers and just professionals around the country. We actually record all of our sessions, which are available through our private well class YouTube channel. Steve also hosts monthly webinars on groundwater and private wells for homeowners, as well as environmental health professionals, which are also all available on our YouTube channel. The program also does additional outreach by periodically offering various county health departments these private well brochures that are shown on the slide right now. It highlights best practices for maintaining your well, and it also includes additional information like, what should I test for in my water? And it's a really great tool. A lot of county health departments request additional brochures from time every so often, and we're always happy to send it over to them. And we get a lot of great feedback about this. We also do a lot of other outreach events like attending the Illinois State Fair every year. IDNR gives us a tent where we highlight our program as well as teach kids as well as adults about groundwater issues and how to better maintain your well. We also attend events like the Farm Progress Show, other educational events like going to schools, going to youth groups and teaching them about groundwater and private well issues. And going back to our other programs, WARM is the one that I mentioned earlier. It's managed by Jenny Atkins, who is also at the Water Survey. She manages various WARM stations located throughout the state. Each of these stations collect various data such as surface level of reservoirs, shallow groundwater levels, suspended sediment levels within rivers, soil temperature, soil moisture level, weather data like air temperature, wind speed, and much more. The network itself collects over 2 million data records every year that goes back to the 50s. Some of these historical data as well as real-time data is available on WARM's website. And for some of the data, you do have to request, or you have to provide a data request to receive them, but we regularly receive these requests, and we would be more than happy to provide those data to whoever that's interested in utilizing that data for research purposes. Just quickly, this is a slide again that highlights more in depth of what kind of data that that's collected by the WARM station. I've also included Jenny's contact information for anyone that wants to reach out to her, just to get more information again about the data that's collected and how exactly they can go about obtaining that data set. The following slides will highlight some of the more recent research projects Steve has been involved with. The first is the sampling efforts he was involved with during the spring of 2022 and 2023, where he and his team collected various water samples from homes with private wells to test for Legionella. So Legionella bacteria can cause Legionnaire's disease, and it's been detected in a lot of many hot and cold water taps of homes as well as buildings. And even hot water tanks. There was a big concern once buildings started opening after COVID due to the risk of Legionella colonization caused by extreme water stagnation and building water systems, which weren't being used for over a year because people are working from home. This research basically aimed to identify whether Legionella was a concern in private wells and what level are they to see at what level these Legionella contaminants were being detected. 3 samples were collected from every home that we sampled from, and they're analyzed using the IDEX's Legion Alert, which detects Legionella through enzyme reaction, as well as the CDC's traditional culture method. Through the analysis, we were able to find out that 32 of the 75 homes that we tested had positive hits for Legionella or viable Legionella in their hot water. So it might have not have been active. It could have been dead Legionella bacteria, but we were able to detect that they were there at one point. So what exactly did this research tell us? Previously, health departments estimated that around 10,000 cases of Legionnaire's disease were reported annually, but since many of those were reported by communities, it's been commonly believed to be very much underdiagnosed. It's actually believed that there can be up to 50 to 70,000 cases every year. So this research also told us that many of the home systems on private wells don't regularly disinfect their water, allowing Legionella bacteria to survive within their water system or within their pipes, and increasing their risk as well as increasing the risks to Legionella formation. We also noticed that many of the health studies only test for Legionella pneumophila, or L. pneumophila, which is only one of the roughly 60 Legionella species that have been referenced in many published articles. Legionella is very resistant and can survive in very harsh conditions. So it's very important to include all the other species whenever you're doing any kind of Legionella sampling. We also found that every testing method for Legionella has some level of limitations. For example, the Legio Alert provided false positives for Legionella pneumophila, which is kind of concerning, but even the CDC culture method itself had very variable results depending on the lab that tested certain samples. There's also a lack of research on Legionella in general in homes with private wells, and we believe that there has to be a little bit more of a need for proper guidance for homeowners to test for Legionella and better ways to mitigate that colonization from happening within their private well. Steve is also currently involved in a project between the U of I Civil Engineering Department as well as the Washington University in St. Louis to develop a innovative method to test for water quality using home POU or point of use filters. The basic idea is to create a service and standard practice where homes can send in their POU filter to be analyzed for contaminants which might have been trapped in the filter to better understand their drinking water quality. This reduces the complications and errors that arise with homeowners testing or collecting water samples themselves to get tested and provides an easier solution for homeowners to test their water. A good example is for PFAS, depending on what kind of clothing you're wearing that day, that can potentially contaminate your water supply or your water sample that you're collecting. So having a service like this that's much easier for homeowners to be able to provide samples, it's a great opportunity. The project itself is funded through the NSF Convergence Accelerator Program, which offers researchers and innovators the opportunity to accelerate their research towards tangible solutions that basically make a difference to society. The project's just started at the beginning of this year, and the collaborative team are currently in the process of refining their approach for collecting and testing POU filters, finding partners that would be interested in working with them, so testing, as well as providing samples, and to develop a sustainable funding model for actually being able to provide this service. They currently have 8 months to complete these tasks to develop a phase 1 proposal, and will be competing against 15 other teams for the phase 2 award, which will add another 2 years to this project. Outside partners such as RCAP, EPA, and the Water Quality Association are also involved with our team. And finally, Steve and I are currently involved with the new EPA Category 3 National Water Infrastructure Environmental Finance Center for small rural and tribal communities project. The program itself is aiming to help underserved communities within the country access federal funding from the 2021 Bipartisan Infrastructure Law, BIL, funding. RCAP was selected as one of those EFCs, and we are working with them to create a interactive GIS mapping tool, which will help them identify underserved community with a higher concentration of private wells or decentralized wastewater system like septic systems, and to help identify those communities that would benefit from connecting to centralized water or wastewater because of maybe public health concerns, or because those areas have been historically neglected or is experiencing environmental justice or EJ related issues. Once we develop this tool, RCAP will then find those communities, visit those communities, and help them use BIL funding to, again, help them get connected to centralized water or wastewater. It's a 5-year project, and we're currently creating we're in our first year of the 5-year project, and we're currently in the process of creating a database collecting private well and on-site wastewater system data from various states to better understand which states this project will benefit the most from. So if anyone of you are interested in any of the research that I just covered today, please feel free to reach out to us. I've included myself and Steve's contact information. We'll be more than happy to give you a demo of our outreach program, talk to you more about it, as well as give you a highlight about the research that we've been conducting. Again, appreciate being introduced and having the opportunity to talk today, and I'll be more than happy to answer any questions if there are any. Thank you.
Thank you very much, Dr. Terashima. That brings us to the end of the presentations from our panelists. I want to extend my thanks to them for allowing their research to speak through them. It was very informative. A lot of information was shared, and I'm sure you can see areas that we can collaborate on. And as was mentioned by many of the speakers, you can reach out to them and make contact, and I'm sure people are thinking about that. But before we go on, it's now time for Q&A. If there are any questions that anyone has to pose to any member of the panel, I had indicated that those who are listening in on the YouTube channel may post those questions in the chat, and we will then table them if we can pose it to whichever panelist you wish, so we can get a feedback. If there are any, and our panelists themselves may have heard something that they wish to get some more information from one of our colleagues on, then sure, you can advise of that, and we will have that discussion. Now, I've been listening to all of this. I don't know if people were like me. I mean, I found it a lot of information, a lot of useful information. I learned a lot of stuff. And as an entomologist, I was happy about some of what I was hearing. I know not everything excites everyone. So things that will excite an entomologist won't excite a physicist and different things like that. But the information was very, very useful. And I know we're thinking about ways in which we can collaborate, and we know that will go forward. What we're doing today is sharing that information, and it's great that the teams got together, organized this, so we can see what our colleagues from the University of Illinois and colleagues at UWI are actually doing, and to see where there are areas where for new research that we may wish to take on. You know, I'm sure people are thinking about, you know, machine learning and how that may play a role in how we do some of what we do. But we started all the way where we, you know, looking at climate, and we know the impact of climate. We heard about the direct impact that climate may have on us, but then we heard on the impact it may have on insects. And people may say, okay, I'm not too concerned about the impact on insects, but because these insects that you're looking at the impact are actually vectors of diseases that affect the human population, and of course it came across, and you know, we started getting concerned about how do we assess the likely impact on public health. And so all of that we can see a system here. So you have the case in Illinois. Jamaica is an island ecosystem. It differs, and there obviously would be some ways of collaboration between the two teams to generate some new and unique knowledge that we can share with the world about climate change, insects, and the disease they spread to the human population. If there are any questions, we would be happy to take them. I'm not seeing any questions at the moment, and if I'm not seeing any, the assumption is that my panelists, you all spoke very well and you spoke clearly, and everybody's minds are now working to see exactly, you know, the ways of collaboration. And I'm sure for those who have shared their emails, they will actually indicate, you know, take that down and make contact with persons to see how we can go forward. All right, Dr. Curtis.
Thank you very much, Dr. Dwight. Just to share with everyone that's here, all the panelists and the guests, that we'll share the link from today's session and for the second session to come with all of the participants, along with contact information, so that the conversations can continue. So at any point, you can either reach out to myself as well, and I'm putting Jaffe on the spot, but I'm sure you can reach out to Jaffe as well, who was our liaison with the University of Illinois at Urbana-Champaign. So thank you very much again to everyone who's here today.
All right.
Curtis?
Yes, go ahead. Please.
Hi, this is Jaffia. I was just wondering, are there any specific next steps that you want to articulate based on this part one session? For the presenters or for anybody else that was listening in?
If I may, Dr. Dwight, Jaffia, it was really yes to begin the conversation. So we've all heard what each of the participants has been engaged in. So we'd like to push the conversations forward. It would be nice if we could give each of the participants an opportunity to review what was shared today, and then we could probably make arrangements to have a follow-up conversation so that we can take the maybe see where there can be some intersection and some further discussion on where we can go.
Thank you.
Right. So we heard, and I know there's a lot for them to go through and to absorb, because as I sat here and I listened, you know, I said that's a whole lot of information. So you can listen and see, okay, who are the persons you may wish to talk to some more to see how we go forward. So I haven't seen any questions, and you know, we had said about an hour, and we are heading down to an hour and a half. So since we have no questions and persons need to sit and digest some of this information, and we as you heard from Dr. Curtis, the information will be shared, and so persons can take a deeper look at it and then reach out to the members of the team to see how we can explore some greater levels of collaboration. But I have no doubt that based on what I've heard, there are a lot of areas on which we can collaborate, and I look forward to the continued discussions and to see exactly what can evolve from this. So just making my last check to make sure there are no questions before I proceed to wrap this up. So I haven't seen any questions. So I would want to just express my sincere gratitude to all the colleagues from both UWI and University of Illinois Urbana-Champaign for taking the time to share the good work that they're doing with us. I would want to thank the persons on both ends, Dr. Curtis and Dr. Jaffe, for pulling this together and bringing both our teams together. This is very useful, and we look forward to it. And I want to thank the support team at UWI, Terry Ann and the colleague from MITS, Sir Preston, for helping us to work things out so we could have this going. And for those who are listening in on the YouTube channel, thank you very much for joining us. I am aware that there are persons out there listening, as at least one person contacted me directly to say, let me know they were listening. So, and these are persons that we will also discuss, have discussions with, to see what we can actually do and how we go forward. I just want to express a big thank you to you all. And please remember, this is just part one. And if you thought part one was interesting, we can promise you, now that we have an idea of what is possible, part two, which will happen in March, will be even better. So please join us then as we continue this discussion to see what good collaboration can come between UWI and University of Illinois Urbana-Champaign. Thank you very much, everyone. And thanks for joining us. It was a pleasure having you all here.